Test. Hi, everybody. Sorry for being late, but we're actually not because it will start at 7:30. So, first of all, thank you all for being here. I want to just say thanks to Workfront for sponsoring this event, and also thanks for ISTC for hosting us. I am Nane Vartanyan. I work as a software engineer at Workfront Armenia. And microservices is one of the topics that I like to start the discussion going. You have probably at least once thought to yourself on how microservices are far better than monoliths. And if you actually worked on a monolith, you would say anything is better than monolith. And then you will have these little services, each running in peace. But if you grow a bit and then have say hundreds or thousands of those, that does not quite look like a paradise. So today we have a very special guest who will share his experience and expertise on how to successfully implement microservice architecture. Tom Valletta currently works as an enterprise architect at Workfront, but has been on and off on being an architect because of his passion to coding. He's fond of working on hardware drivers, intelligent robots, and just breaking web technologies out of the browser. Also, last but not least, he's a super father of 4 wonderful children and just the kindest person. So I'm very happy to have you here today, and let's just welcome Tom on stage.
Thanks. Like she said, I've been an architect 3 times. Every time I've been an architect, I've only lasted 2 years, and then I've quit because it's really hard for technical people who like to code to just go to meetings all day, and that's kind of what architects do. But I'm happy to be an architect for Workfront again, and I am excited to share with you my ideas about microservice architecture. So, like she said, I work for Workfront as an enterprise architect. I also spend my hobby time building node rockets, which is a robotics project. And I typically participate in conferences doing hands-on robotics activities because I really like robots, because I'm a nerd. I was excited to talk about microservices because I think that a lot of people think that microservices are the answer to everything. This is how we commonly approach new topics in the industry. We think that the next thing is going to solve all the problems that we have had before. And microservice architecture is just a new set of trade-offs. In fact, it's not very different from service-oriented architecture, which is what we tried 10 years ago, and we failed to get right. So 87% of service-oriented architecture projects ended up in failure. And I want to go through how to not make the same mistakes with microservices. First off, I'm supposed to tell you that in the Facebook link, there is a link for a voter that you need to pull up on your phone or your laptop or any device that you have, because I have participation built into the presentation. So I'm going to... So you see the pie chart that I'm showing down in the corner. It's kind of cut off, sorry. Someone voted for yellow. So when you get the voter up, there you go. If you would just go ahead and vote yes or no, we're going to use this at different phases of the presentation. I like this because it lets me get the sentiment of the audience without asking you to raise your hand. Because if I say, who's doing this wrong? Seldom do people want to raise their hands to that. And so this is an opportunity for me to get truthful feedback and people don't feel awkward about voting. So if you're interested in participating, yes, it looks like people are. Just keep voting yes or no. You don't get unlimited votes. If you vote yes and then you vote no, it takes away your yes vote and just changes it. So you don't get 1,000 votes. Okay, so that's excellent. I'm going to hide the voter, and then when we get to certain stages in the presentation, I'll ask for your participation and see what we think, okay? So I don't want to spend a lot of time here because I feel like this is pretty well covered on the web. A lot of people understand the pros and cons of microservice architecture. I just want to quickly goes than it is to scale something huge. And the reason for that is when you build small microservices, some microservices are going to use a lot of CPU, depending on what they're doing, and you can scale up by CPU. Other microservices are going to use a lot of disk I/O or network or memory, and you can scale based on the characteristics of that microservice. When you have lots and lots of features built into a monolith, it's very difficult to scale a monolith in any thoughtful way. All you can do is just throw tons of hardware at it and hope that it's good enough, right? And so scaling is obviously an advantage of microservices. On the cons side, the disadvantages of microservices, and this is where I'm going to spend a lot more time, because later on in the presentation, I want to address how to overcome these disadvantages, is availability. It's usually pretty easy to keep one application up and running. If you have a reasonably skilled infrastructure team, they can keep one app up and running pretty easily. But when you give them 10 services or 100 services or 1,000 services, it's really hard to keep everything up, and you can't do it the same way that you did it with a monolith. And so this is more difficult in the microservice realm. Back on the pro side, workload partitioning, this is just the concept that it's easier to work on things. Things are simpler when they're smaller. So as things get bigger, you have a lot of different interactions. It's harder. And so if you can isolate a problem into a smaller piece, then it's easier to approach. It's easier to reason about. And so it's also, I like to point this out. So when you're working on a monolith and new features are added, developers don't feel like they're working on anything new. It's just a new feature in the same old crappy project that they've always been working on, right? But if you did that new feature in a microservice, every new microservice is a new project. And every engineer likes to work on new projects, right? So it's kind of a morale thing. You get to make new decisions. You can decide not to go with Java 6, and you can go with Java 12 instead. It's liberating. On the con side, operational complexity. This is a lot of the downsides to microservice architecture are intertwined. They all have to do with the fact that you have to manage a lot more things. And so microservices is all about trading operational complexity for speed of development. So because microservices end up being a distributed system, it's really difficult to manage distributed systems. It requires more mature tooling. Usually you have to do Kubernetes or some kind of a Docker orchestration, container orchestration, in order to get microservices to work. And if you're not accustomed to that, it's a new set of tools that you have to adopt. So one of the good parts about microservices is that you can just build something and deploy it to production, and there's less coordination that needs to happen because you're deploying smaller pieces. On the flip side of that, it's harder to coordinate releases with microservices. When you're building a monolith, you can get all the teams together and say, all right, when you're done with this and I'm done with this, then we'll ship the code to production. When you're building microservices, if you say, all right, as soon as you're done with that feature and I'm done with my feature, then we'll both hit the deploy to production button at the same time. Like, that doesn't really work. It doesn't work for 2 microservices, and it definitely doesn't work for 5 or 6, right? And so you have to have a new strategy for release deployment when it comes to microservices. And that's when we're going to talk about feature flags. So on the pro side, everyone likes to talk about polyglot. There's a lot of people who hate that word because they're like, hey, my language does everything. If you can't get it done in Java, it can't be done. And so sometimes people don't like that. I think that polyglot can mean a lot of different things. Some services are going to be, they're going to perform better in a different language. Sometimes, if you need to do image manipulation, Java might not be the best solution for that. You might need to use C for something like that. And then there's other frameworks and languages that are specifically built for different purposes. So on top of that, if you're in a monolith and your monolith was at Java version 8 and you need to get it to Java version 11, it might take you several months to get there because you need everyone to buy in. And when you're in a microservice world, you can just start on OpenJDK or Java 12, and it doesn't matter what other services are running on. So this is a big deal. It's good for recruiting. It's good for innovation. It's good for letting people make choices and be autonomous in their decisions. Okay. Development dependencies. So this is one that most people don't think about when they approach microservices because you have to get down the road a little bit with microservices. If you build your first microservice and you're all excited and you deploy it to production, and let's say it's using Java and Oracle. So you have Java installed on your local machine and you have Oracle installed on your local machine. And then you decide your next microservice is going to be done in Ruby and MongoDB. So you install those on your local machine, but maybe you have a dependency on your last microservice, and so you still have Java and Oracle. And then you start working on your third microservice, and that's going to be done in Python and Postgres. And so now that you've installed everything on your computer, it's hard to keep all that stuff under control. So development dependencies can be a really big deal. It doesn't hit you right at first, but as you build more microservices, it becomes a real impediment. And so we'll talk about how to deal with that. This is not a con, the last one. It just happened to be in line with development dependencies. When you are building microservices and you're building it locally and you can just rebuild in like 3 seconds and run all your tests in 8 seconds, it's a pretty awesome thing compared to working in a monolith where that takes minutes or lots of minutes. And so it's a big deal. All right, last ones. Ownership and accountability. This one is more nuanced. When you work in a monolith, unless you own the whole thing, which it's really hard to do with a monolith, it's hard to feel like you can make any choices as an engineer. It's hard to feel like you can innovate because you're stuck with all the technologies that are already there. So when you move to a microservice world, and every new service, you get to choose a new set of technologies that best fits the application. It's liberating. It lets you be more accountable. Plus, in a microservice world, you have to be able to own your services in production. And so you have to own more of the stack. And we'll talk more about that later, too. The last one is the worst. If you work in a system that has a lot of services, you'll quickly find out that debugging distributed systems is really hard. And there's a lot that you can do to make it easier, but it's just hard. And so if one service goes down and there are other things that are dependent on it, and those go down, and then there's things that are dependent on those, and those go down, it's sometimes hard to track down the service that took everything else down. And so you have to have a new set of, you have to be more disciplined in your development approach in order to make that work. Okay, so those are the pros and the cons as I see them. I'm sure there's more. I'm sure there's ones that I've missed. But those, I think, are the big ones in my experience that cause people problems. So now that we know that microservice architecture is where we're trying to get to, if that's the destination, I want to take a step back from microservices and talk about the things that we have to do first in order to be successful with microservices. Let me point out that my little Minecraft island there with the tree has a treasure chest on it. I know the treasure chest is small. I've gotten feedback that it looks like a llama or a sheep, but it's really a treasure chest. Okay, so treasure chest island, that is microservices. In order to be successful with microservices, I have 5 pathways. The first one is, oh, my link got cut off. It's okay, it doesn't matter. DevOps culture. So DevOps is a lot like microservices, where people use it to mean whatever they want it to mean, right? So it's like this ambiguous term that, like, yeah, if you want to be successful with blah, 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 just do blah, blah, blah. That's not helpful for anyone, right? So let me define what DevOps culture is. Let me first tell you a story. I started working for a company that said, yeah, we're all in on microservices and we're all in on DevOps. And I said, oh, how did you make the transition to DevOps? And they said, we took our operations team and we renamed it to our DevOps team. Okay. So I think their transition wasn't complete. But a DevOps culture means to me that developer and operation roles need to reside on the same team. This means that when you build your microservice, you have to also be able to deploy your microservice by yourself, like not hand it off to someone else, because there's no infrastructure or operations team that can handle hundreds of services and keep them all up. The team that builds it is the team that has to deploy it and manage it. So that's what DevOps culture means. And in order to be successful with DevOps culture, you have to have autonomous teams. That means that teams must be responsible for all aspects of software delivery. And when I say responsible, I don't just mean that, like, you hold them accountable if something goes wrong. They have to have permission and authority to make the decisions to support their applications in production. So autonomous teams means the team can stand on its own. It owns its software from beginning to end. In order to be, a team should be able to design, build, test, deploy, and maintain software in production. That's what that means. And in order for that to work, you first have to have full stack teams. And when I say full stack teams, I don't mean full stack engineers, like, oh, you can do the front end and the back end. I mean, a full stack team can do the operations work, the QA work, the database work, all on one team. And that doesn't mean that one person has to be able to do everything, but the most successful microservice teams that I've ever been a part of have been 4 people doing all of those roles. And if someone's sick or on vacation, the team can still operate. So that's what a full stack team is. So this is where, oh, I should have been voting earlier. Let me show this again, and let me reset it. Okay, now that I've reset that, if you could pull open your voter and tell me how many of your organizations are already doing this. So vote yes if your organization is doing this, and no if it's not currently doing this. Okay, excellent. Thanks for voting. So it looks like about 25%. Oh, and growing every minute. So about a quarter of the organizations that you work for already have full stack teams. So let me then reset that, and let me ask this question. How many of your organizations are doing microservices right now? So yes if you're doing it, no if you're not. how many of your organizations are doing microservices today? If you work for an organization that's already doing microservices, vote yes. Okay, so a little bit more. Okay, that's good to see. That's helpful. We'll vote more frequently on some things. I think that that's valuable to see where we land, right? Do you guys like that? I kind of like it. Sorry, I'm nerdy. I like dumb stuff. All right. I'm going to hide that, and let's go to the next one. Okay, so full stack teams helps to address the availability issues of microservices. Okay, so let me check time. Okay, there's 5 pathways, and we've done one of them. So this is the next one. Continuous delivery. Frequent small releases allow for greater velocity and reduce blast radius for issues. In order to be successful with microservices, you have to be able to release your software when it's done. You can't build and then wait for dependencies from other teams before you deploy it to production. You just have to build and go. Otherwise, you miss out on a lot of the advantages of microservices. And as more services are added to the ecosystem, coordinating releases becomes impossible. You can't hold up several teams so that you can say, all right, we're ready to go now. You have to let people go all the way to production. And so continuous delivery is required to be successful with microservices. In order to continuously deploy code, you have to have confidence that your tests are going to keep you from pushing bad code into production. So if you say, every time I check in, my code goes straight to production, but I don't have any tests, you're going to be in trouble. I think that should be obvious. Continuous delivery only works if you have good gates for keeping bad code from getting into production. So if you don't have confidence in your tests, there's no way to be successful with continuous delivery, right? I think it makes a lot of sense. Some people fail to see the connection, but when you talk about it, people seem to get it pretty easily. So, in order to do microservices right, you have to do continuous delivery. And in order to do continuous delivery, you have to have good tests, or at least confidence in your tests. In order to have confidence in your tests, you kind of have to have good coverage. Now, I don't really like this step because I'm the first guy at the organization when someone says, we need 100% test coverage. I'm the first guy to fight against it the whole way. I hate 100% code coverage. I think it sucks. I think it creates the wrong motives for engineers. Engineers end up building tests just for coverage, and then when you change your code, the tests that were built just for coverage break, and then you have no confidence in your tests anyway, so it's horrible. But I do think it's important to have 100% feature coverage or 100% logical branch coverage. And that's not the same as line coverage or code coverage, but it is kind of close. So I'll let you figure out what that means, but I don't think that you can have test confidence if you have 30% of your features covered, right? It's hard to say, like, when I push my code to production, I know nothing's going to break because I have 30% of it covered in tests, right? Okay. Let's vote. I'm going to reset. So if your organization has tests that you can rely on, you're confident that your tests keep bugs from making it into production, vote yes. If you think that maybe your tests are insufficient to be successful with continuous delivery, vote no. Okay, so it seems like about a third of people think that they have enough tests, and most people don't. That's interesting. I don't think that's surprising. Even when I've had really good tests, I sometimes say we don't have enough, right? Like it takes a lot of tests to be confident, right? And you have to have a pretty good test strategy. And the other thing that I think is hard about this is you have to trust the other people on your team know how to write tests well as too. And sometimes that's hard. Not that you don't trust your team members, but you know what I'm saying. All right. Okay. That's going to help with operational complexity. Okay. 3 down, 2 to go. Was that the third one? This is the third one, huh? Man, I don't know how to count, huh? All right. I've changed that a couple times, but it's still wrong. Sorry. Okay. That's the same step that was on the last pathway. So continuous delivery, we already talked about that. But there's other things that we need to get right before we can be successful with continuous delivery. Independent releases. So I believe that you can't be successful with continuous delivery unless you can release independent of other microservices. So you can't say, I'm pushing this code to production, but I have to stop it until someone else has their code ready to go. Or some other service has some other integration that's necessary in order for my code to go to production. You need to be able to release independently. So when your part of a feature is done, it needs to go all the way to production. Even if it's relying on other services to be complete, your code still has to be able to go to production independently. In order for that to work, you have to use feature flags. So this is the only way that microservice releases actually work. You have to have a global feature flag system that allows you to coordinate releases between many services and turn them on and turn them off all together. But the code has to be in production or some lower lane altogether in order for this to work. So using feature flags as a release mechanism is important to be successful with microservices. Does that make sense? Okay, let's vote on that. So I want you to vote yes. All of you vote yes. No. I want you to tell me if your current organization does most of its development behind feature flags. Wow, this is a good one. We're better than most of the other ones on this one. This one is a little bit easier to achieve. Even if you're working on a monolith, this is a valuable thing. And so it's great to see more people doing this. Okay, let me ask another question, and this is just from my own curiosity. Let me reset the voting. Now I want you to answer this. Is the feature flag service that your organization uses one that they built, or is it one that you have purchased or licensed? So vote yes if your company built it yourself, or vote no if it's a feature flag service that you're licensing or purchasing, a SaaS product. like Split IO or Launch Darkly or one of those. That's better than I thought. So I just have bad experience with this. The last 4 companies that I've worked for have all built their own feature flag service. It's a horrible thing to do. Don't do it. Everyone thinks, oh, it's so easy. All you have to do is store a Boolean in a database, and that's all you need. But feature flag services have come a long way. They tell you when you can remove dead code and turn off feature flags, and they allow you to release code in like 90% to one audience and 10% to another audience. There's a lot of things that feature flag services do. I understand if you don't want to pay for that because you're a small organization, but at the same time, it's not as simple of a problem as you think it is. And once you start using a real feature flag service, you'll realize what you missed out on. Anyway, that's interesting to see. Okay, that was the third one. And feature flags help us with release coordination. 4, learned how to count by now. Okay, container orchestration. So that's a complex word that just means Kubernetes nowadays, right? It used to mean Kubernetes or Docker Swarm or Mesos. There are a lot of those, but now there's just Kubernetes. No one uses anything else. So I could have just put Kubernetes there. But microservice architectures attempt to simplify through modularity, but they do this through increasing operational complexity. So this is the trade-offs that you get from microservices. This is the reason why service-oriented architecture failed 10 years ago, is because they tried to do what we know today we should be doing, but they had none of the tools that we have today to do it. And so they failed at maintaining the operational complexity, and so it didn't work. Now we have better tools, and so in order to be successful with microservices, we should learn from the history of the past where we failed with service-oriented architecture and use the tools that are available to us. So in order to be successful with container orchestration, I think this next one is going to be pretty obvious. You kind of have to have containers. And so teams need to leverage containers to encapsulate complexity and leverage automation. Containers are easily run and shared. Many of the costs of polyglot development are offset by the use of containers. So before, when you tried to say, like, hey, anybody can write their own service, you can do it in Java, you could do it in Python, you could do it in .NET, and then you hand it over to your operations people, and now they have to learn how to manage like WebSphere or WebLogic or Tomcat, and they have to learn IIS, and they have to learn how to do Express for Node and whatever you use for Ruby and all those things, right? So that's why it's hard. Now with containers, no one cares. You just give them a container and it works like every other container. So it makes it easier. So in order for this to work, you also kind of need containers in development. And this is something that I think a lot of people don't do, and I can't figure out why. Because when you start microservices and you build your first one, we talked about this a little bit earlier, and you're using Java and Oracle, and then you build your second one, and that's using Python and Mongo, and you build your third one, and it's using something else and something else. You can't install all those things locally. So if each one of those has a Docker Compose or just like is containerized, then it's super easy to load those other microservices down and they all work. And then when you need to move off onto some other platform or stack or use some other database, it's really easy to just throw it all away and pull down the next thing. So for the last few years, I've been using containers for local development. When I first started doing it, it was more difficult than what I had done for the last 15 years, right? Because everything familiar seems easy. However, once I started using Docker for development, I couldn't imagine doing development without Docker, because everything's way easier once you make that shift. But it's hard to understand why you need to until you do it. It's like getting your cell phone, except that that's not a really good analogy anymore, because everyone here was born with a cell phone in their hand. But in my age, people didn't have cell phones, and then they bought one, and their friends all said, "Why do you need a cell phone? I get along just fine without a cell phone." But then they all bought a cell phone, and then they realized why they couldn't get along without a cell phone, right? So that's how Docker is for development. I know that's a bad analogy because no one understands what I'm talking about because you're all younger than me. Anyway, sorry. Okay, so let's vote on this one. So vote for this. Show reset. Whoa, already. You don't even know what you're voting for, and you're voting. Let me reset that and give you another chance to vote. So if you already use containers for your local development, vote yes. You use containers like Docker for local development. It doesn't have to be Docker. I know that Docker is like the 99%, but there are other containers that you can use. Cool. That's more people than I expected. Nicely done. So you do development inside of the container, or you just use it for other things that you're connecting to? Okay, for connecting to? Okay, that's good. That's a good start. So let me ask the other question then. So how many of you, and let me reset this, vote again. People are still voting. Hold on. Okay. How many of you do development? People just want to be the first ones, huh? Okay. Maybe we should get that out of our system. Okay, if you want to be the first one, I'm going to hit reset right now, and you hurry and vote. Ready, set, go. Yes, you got it. All right. Okay. If you do development inside of a Docker container, so the code that you're working on is in a Docker container, vote yes for that one now. That's a lot less, huh? That's okay. There's stages. You don't have to do everything at once. It's cool. All right. Interesting. Great. Okay. Where are we at? Good. So development dependencies, that's a difficult issue when you start working with microservices, and this is the way to address it. Okay, last one. So in order to be successful with microservices, you need to adopt share nothing architecture. So this is a foreign term to a lot of people, but basically it means you can't share your persistent state or your cache with any other microservice except through your API. So this is a hard one for some people, and it's especially hard for people who really love relational databases, because relational databases are all about putting your data right next to someone else's data and doing joins on it, right? You want to join everything up. Thousands of joins. Everyone share everyone's stuff. So that's great, but that doesn't really work in microservice architecture. You can't do it. And so when people do microservices, I tend to recommend to use a non-relational database. Even though relational databases are great for a lot of things, and I'm not saying that they're not. All I'm saying is, if you force yourself to use something like Mongo or Couch or something that doesn't have joins, you won't be tempted to try to put other people's data in there because it won't do you any good, you can't join on it anyway. So it's good because it forces you to think the way that you need to think for microservices. I'm not saying that Mongo is better for microservices. I'm only saying that it helps you think the way that you need to think for microservices. You can still use Postgres or whatever you like. Okay, so on this topic, there's a really good email that I like to share with people. It's by a guy whose name is Steve Yegge, Y-E-G-G-E, and he used to work at Amazon. And when he worked at Amazon for 6 years, and then he went to work for Google. And I think he went to work for Google because he hated Bezos. In fact, I think in his email that he is publicly available, it's really long. It's like a 20-minute read in an email. But in his email, he says, Bezos is the devil. He hates him, and he thinks he's the worst person on earth. But he said that Bezos did one thing for Amazon that makes them better than Google. He said, Google does everything right, and Amazon does everything wrong. This is one guy's opinion, right? Google does everything right, and Amazon does everything wrong, except back in 2001, Bezos said to all of his teams, if you ever let someone have access to your data that's not through your public API, I will fire both teams. And then he said, have a nice day. But then Steve Yegge says, he actually didn't mean that because he doesn't want you to have a nice day. He wants you to burn in hell. But he said, you can't share data. So the reason why this email is important, and thousands of people have read this email, is because he makes a really good point about how Amazon has been so successful despite doing everything else wrong. They got that one thing right. And Google, doing everything else right, hasn't got that one thing right, and so they're struggling to build a platform. And now this email came out in 2009, and so it's kind of old, and Google has come a long way since then. But it's really interesting. It's worth your time to go read it, but it talks about sharing nothing, and that's how you build a platform that's as successful as AWS, right? Okay, so that was a long one. Sorry. Oh, and I never hid the thing. Here, hold on. Okay. So in order to be successful with share nothing architecture, you have to have thoughtful APIs. You can't say, hey, I'm not going to give you access to my data unless you go through my API, but my API really sucks, right? Like, it's hard to say that to your peers and your customers. And so APIs have to be built to contracts. They have to be built to a common standard, and they have to be versioned and documented. I think that this is like pretty basic stuff, right? This is easy or easier. The next part is a little bit harder, and it's resilience. So resilience is a hard word. Let me define it. Resilience means that something is flexible and stable. If something happens to it that it doesn't expect, it bounces back. And so your APIs must be resilient. Failures always occur. You will always have a database go down. If your database goes down and then your service collapses, because what's it supposed to do without its data, right? And then when your service collapses, other services that are dependent on yours, what do? They die as well, right? And it ends up being like ripples in a pond, chain reaction that takes down your whole system, right? You can't have that. That adds to the complexity and the issues that occur with distributed systems. So if your database goes down, that's just a dependency. You need to still make sure your application stays up. You need to respond to your customers' requests with reasonable errors so that they can understand why you're not giving them the data that they want, right? And then you need to log it appropriately. So in order to be successful with microservices, you have to build resilience into your APIs. Does that make sense? Okay, this one's a hard one to vote on. Like, what do I even ask for this? I don't know what to ask. Okay. Do you have thoughtful APIs? No. There were a lot of no's really quick there. Okay. That's pretty good. Let me ask another question. So now I'm going to ask, does your organization believe that no data or state should be shared between microservices or bigger services without going through an API? No one can touch your data except through the API. Okay, I'm going to reset. Now answer that. Yeah, nice. Good job. Okay. And it keeps growing. It's getting better and better. Everyone just change your vote to red. It doesn't matter. Okay, so that's the fifth pathway. I think that if you can do those 5 paths, you will be successful with microservices. If you can do those paths halfway, you'll be pretty successful with microservices. This will get you off the ground and get you into a good state. At least it'll get you to the point where I've worked with a lot of people who say, I tried microservices, it sucks. It's so hard, so we just went back to the monolith. And like, there's a lot of people who say that. And I believe them. It's hard. If you don't do these things, I promise you'll love monoliths. Because microservices just aren't going to work for you. Okay, we're done with the 5 pathways. How much time do I have? I still have 2 minutes, right? Or 12? 2, okay. Okay, so that's resilience. Okay, so there's some other problems that you're going to run into. So I know that we talked about all those things, and you're going to be successful with microservices because you're already doing half of those things, and you're going to do the rest of them. But there's other things. Once you start down the microservice pathway, the microservice road, you're going to run into these things. There's this thing called a distributed monolith, where you start to build microservices, but all of your microservices have hard dependencies on other microservices. And so then it just becomes this like big complex system where everything is dependent on everything else, and there's tight coupling between everything. And so in order to run any one of your services, you have to run all of the other services. It's called a distributed monolith. It's what happens when people don't think through the problems of decoupling their systems. So watch out for that. There's 2 types. One type is everything's tightly coupled. The other type is when all of your microservices require a shared library that everyone has to use on all of their microservices. And then in order for you to update that library, you have to update it simultaneously across all your services. That's another type of distributed monolith, because in order to update that module or that package, you have to take everything down to do it, right? So those are 2 anti-patterns that once you start heading down the road, you'll run into. This one's another common one. People always say, in order to do microservices, I need to decouple things, and so I'm going to create an event bus, and then I'm going to make my event bus super smart so that if anybody puts anything on, my event bus will call around and call all the right people and tell what services what to do. That's a really bad pattern. It's called an enterprise service bus. We don't do that anymore. We learned our lesson 10 years ago, but people, when they try to do decoupled communication between services, they always, for some reason, try to build it into the bus. Don't do it. Keep the bus dumb, make smart connectors. It's the only way it works, okay? And then the last one is layered microservices. There's going to be someone on your team who's going to be like, hey, let's do microservices so that this microservice talks to the database. And this microservice has a bunch of logic that talks to the microservice that talks to the database. And then this microservice is the back end for the front end, and it talks to the other one. And you do this like cake or this onion where you have to talk through several layers of microservices to get to the back end. No, don't do that. Everyone tries that for some reason. I don't know why. Like, it seems like a good idea because that's how we built monoliths in the past. So like, hey, let's do that with microservices. But don't. Microservices should be front to back, vertical services rather than horizontal layers. Does that make sense? Those are things that you'll get to in the future once you're down the road with microservices. I just wanted to let you know those are important things, but maybe not important until you're already down the road a little ways. Anyway, so that's all I had. At Workfront, we're hiring. I want to show you that we do a lot of cool stuff. We're doing microservices, kind of. We are disaggregating a monolith and creating a bunch of new services, and we understand where we're going. So it's a lot of fun. We use a lot of great technologies. We invite you to join us, or at least see if it's the right thing for you. Thanks. Questions?
Yes, we can take a few questions if you have ones. Okay.
Hi, first, thank you for a great talk. I have a question regarding not sharing data. It's obvious that the microservices should not share data, but what to do in cases when actually you want to enrich the data? So you have an API and you need the data from one microservice, but also need to enrich it at some point to give back to your front end. There are a lot of different approaches, but I would like to hear what is your best solution, or according to your experience, what you are using.
That's a great question. So she asked, when you have to join data or you have to enhance data, what's the best way to do it? I don't believe that there is a best way to do it. I'll tell you some of my favorite ways to do it. So it's okay in microservice land to replicate data or to cache data so that you don't have to always integrate with all the microservices. Sometimes that requires a lot of syncing, and that's not great. One of my favorite approaches is to use something like Elasticsearch, where you combine multiple sets of data into a projection or a materialized view, some kind of a composite index for doing that kind of work. The nice thing about Elasticsearch is no one thinks that it's the source of record. So it keeps a strong separation between who owns the data and accessing a joined set of data. Then we do a lot with data lakes and aggregating data at different layers downstream, but it's not transactional. So those are some of the ways that I like to do it. I usually choose the simplest way first, and then when I realize that that won't work, I try something more complex. Thank you.
Anybody else?
You mentioned that we should have dumb pipes and instead have smart connectors, and we should avoid this enterprise approach. Why? I didn't really get the point.
Oh, that's a good question. So there's a lot of history. 10 years ago, everyone thought that enterprise service buses was the right approach, where everyone just talks to the bus. But then the bus got really complex, and it was doing all sorts of really complex logic to route different messages to different services. And it became impossible to maintain the enterprise service bus. And most organizations ended up building large teams, lots of people, just to maintain the bus and the complex routing. It didn't add to, it didn't help. It just made the whole situation more complex. There's a lot of articles written about why not to use an enterprise service bus. They would do a better job at explaining that than I would. I hope that answers your question. Yeah.
Are there any other questions? No, okay, thank you. So we have just a little bit time here, so if you want to socialize and maybe talk to each other or approach Tom, you're free to do so. Thank you all for coming.
Thanks.